Here we go. All right, y'all. It's time for inequalities. Let's do it. So do you remember how yesterday you guys might have felt good about what's going on? Today you'll feel even better. Well, those of you who couldn't hear the lesson, I'm sorry for nothing. All right, let's do it. We're going to solve inequalities. We're going to do the exact same thing we did before, but there's going to be one bonus step. Have you guys ever done Wiggles graphs or interval graphs?
I hate Wiggle graphs, dude.
Well, this time you won't because this is our third time seeing it, right? Whenever you have an inequality, we're going to use test points. Now, with that being said, if it's basic, like this is pretty basic, right? Could you graph it and not use a Wiggles graph? I'll show you both ways, okay? I'm going to show you both ways to do this with using a wiggle graph, using test intervals if you want to sound cooler, or by graphing it. So what's this saying? What's it mean to be bigger than 0? It means you are positive, right? So let's graph it and kind of think about what's going on. Because you guys are really good at graphing. Cosine starts high. What's my period of this going to be? It'll be 2 pi divided by 2, right? Which is pi. So I'm going to go down, then up, and that'll be pi. But now what does this question want? It wants from 0 to 2 pi. So how many periods fit in there? I'm going to have 2 of them, right? You guys see why I drew 2 curves. So where am I going to be positive is from here to here, here to here, and here to here, right? Does that make sense? So by looking at the graph, can I tell where I'm greater than 0? Yeah. Pretty easily too, right? If this is a calculator question, by all means, what should you probably do? Graph it and look at it, you know what I mean? Now, how do I find these actual intervals? I would do, remember that would be what, pi over 2? Cut in half. Cut in half again, I get pi over 4. So each of these is going to be a pi over 4 jump, right? This one's 3 pi over 4, right? This would be, so that's 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. You guys see what I did there? I just took my smallest interval and I kept adding it to it. So based on this graph, where am I positive? From 0 to pi over 4. Now, is that or equal to? No, so am I going to use brackets or parentheses? Parentheses. So from 0 to pi over 4, I'm above the x-axis, union, from 3 pi over 4 to 5 pi over 4. Union, 7 pi over 4, 2 pi. You match the symbol because it's greater than, not or equal to. If it's or equal to, they'd all be brackets. Oh, are you talking about here?
I'm talking about that 2 pi, you go and still be above, and then 0 you go left.
Do you see how that's parentheses? 2 pi is not part of it.
0 is fine.
I would agree with you. I'm going to agree with you. That's not what the key says, but that's right. That's an astute observation. I wonder if that's not a typo or something else. Why? Do you guys understand what K-Dog was bringing up? That's a bracket, right? I'm making that bracket because at 0, do I equal 0? No, I'm above 0. I'm positive. But 2 pi is not part of my interval. That's a parenthesis on there. Does that make sense? My function doesn't reach 2 pi. Like that interval's not including it. Now, if that was a bracket, yeah, I'd put a bracket there. Match your signs, right? Not or equal to. Include it, don't include it. That was good. That's a.
I just got very curious.
See, I do give them out in my AP courses. Maybe if y'all didn't heckle me so much, I would be nicer. Y'all ever think of that? All right. How else could I have done? What could I have done this not graphing it? I'm gonna do a little sidebar over here to compare and contrast. No, I'm gonna pretend like I never saw the graph in my life. Like this is my first day on the earth. What do I do to both sides? Cosine inverse, right? Okay. Where is cosine 0? Pi over 2, right? We're talking normal pi. No, not on the, we're looking just at this. Pi over 2. If I'm using unit circle, it's at pi over 2. So I would do 2x greater than pi over 2 plus 2 pi k, right? Do you remember? Like that's what we've been doing, right? What do I do to everything to get rid of that 2? Pi by 2. So again, I'm showing you another way to do this. X is greater than pi over 4 plus pi k. Or k is there. This is how it works, so I'm not going to worry about it. But yeah, k is definitely an integer. Okay. Hold on though. That's 1. Is there another one too? Is there another 0 for it? What's our other 0? Three pi over 4, right? Remember, we have to do it twice because we're over the whole thing. Divide everything by 2. Do you guys see why I set up the 2? We did this last time too. And I get x is also greater than 3 pi over 4 plus pi k. That's not, we're not done yet. That's just the beginning. Oh, we divided everything by 2. Yeah, so yeah, you're right. That's the original. Oh, because I wrote it wrong here. I apologize. It's my first day.
Oh.
My bad. Whoopsie. All right. Obviously, it's not positive for that whole interval, right? So what we need to do is find all of these that exist between 0 and 2 pi. So we have pi over 4. If I add pi to pi over 4, what do I get? 5 pi over 4. We have 3 pi over 4. What happens when I add pi to 3 pi over 4? 7 pi over 4. Add another pi to this one. That'd be 9 pi over 4. Is 9 pi over 4 on that interval? No. So those are my 4 zeros, right? So then I would test point, plug it in, and see which ones work. And you'd end up with, I'm plugging in 2 pi because I need my endpoints as well. So if you plug it in, you would have gotten positive, negative, positive, negative, positive. And do these intervals match these? Now, in real life, would I ever do the problem this way if it's that one? Absolutely not. What am I going to do? I'm going to graph it, right? That one's so much easier. In fact, hold on, let me see something. I think you're going to be able to get away with graphing for all these. Because you guys, what can't you graph for sine and cosine? Is there anything you guys can't graph? No, you guys can graph everything. You guys can graph phase shift. You know, I mean, you can freehand it, right? And if it's one that gives you crazy decimals, guess what you're going to be allowed to use on it? A calculator. But I wanted to show you this just because that is a thing that exists. And it also reminds you, for inequalities of polynomials, how do we solve them? Find your zeros, set it equal that. So, do I use that method? No. That's why I kind of like had to look a lot, because that's not how I did these ever in my life. Sound good? All right, let's just do one more, and that'll put us in good shape, actually. If I were you guys, I'd have my graphing calculator out for this one, because this is going to be a more common style one that you're going to see. Yep. Yes, this is very, very, very much a graphing calculator question. Yes, because you are going to get decimals across the board. So, you guys have out your graphing utilities? All right, let's, dang it. What? Oh, it'll work. It's the only thing in here that does work. Because I don't. All right, so now, how do you want to do this one? There's two ways to do it. Could I subtract over the sign and see where it passes zero? What way do you guys want to do it? Do you want to do it where you graph both and analyze it, or subtract it or get to zero? That's probably how I would do it too, because then it's easier to look at the graph. But all right, so let's say if you graph both these, you end up getting two graphs that look like this, right? If you do it this way, you would look for when this one's above. This is what the one graph looks like. This is what the other is going to look like. You look for where you'd find the points where that's above it. Does that make sense? But now if you subtract it, you get to just graph and look for where it's above zero. Does that make sense why I would do it that way? Do both ways work? Yeah. In algebra 2, do you remember graphing multiple things and shading like when one's above it? So does that make sense of why I would shade where that one is? And then you'd find those two intersections, right? You'd find the two intersections. Second, calculate intersect. Let's try the subtract method. Could I see where this is bigger than zero? Now this on my calculator, I'll only have one graph and I can look at where it passes the x-axis, right? So let's try it. If you guys got your calculator, I would give it an old college effort. Right now I wish I had like one of those screens that was like a touch screen. That'd be awesome. Be like beep, bop, boop. No? All right, that's, yeah, try, graph it. It's just going to take me a while because I'm, oh. Isn't it amazing that they pay me to do this, guys?
That's why this English doesn't work your side, dude.
Yeah. Never mind.
It's a good job.
Yeah. If you think this is bad, you should see the furniture I've built.
No, I think it's baseball.
Oh, we're going to go. We have a deal on our baseball team. If every time that the baseball team gets mercied, I randomly draw a name out of a hat and they have to shave their head. Because the deal is if you guys mercy someone, I have to shave my head. But then I saw, no, I was going to say actually your first game on your schedule.
Oh yeah, got it.
So I took it off when I saw that. I'm like, oh, trust me, I've heard the stories. All right, what's going to make this easier? Which one should I zoom on if I'm going from 0 to 2 pi? Zoom trig will automatically give me a good graph, right? Do you guys notice what's interesting? If I'm subtracting two trig functions, what do I end up with? A trig function. It's actually just a shifted trig function. But now, what am I looking for on this graph? Where is it? Above 0. So now because there's one graph, I'm going to do second, calculate 0, right? Is this right?
Yeah.
Oh, no, it's right. Left bound, right bound. You guys are old pros at this now, right? And if you aren't, that's fine. Just make sure you figured it out. We get it together. I got 2.09. So I got 2.09. So it's from 2.09 to my second one, which I got 5.24. Yar? Now, am I going to use brackets or parentheses on this one? Brackets because that's bracket. Yep. All right. No, because it's not 0. This one's different. We aren't on the interval. All right, any question on this one? I just subtracted them. Look for where it's greater than 0. Now, I'm going to add a caveat to this. What if I wanted all solutions, a general? What would I do? I would say it's 2.09 plus, what's my period on both these? They're 2 pi. And if I'm combining two periods, they're going to stay the same, like adding, subtracting. Does that make sense? Because they both fluctuate the same. So I'm going to do plus 2 pi k, comma, 5.24 plus 2 pi k. Where? Okay, exists as a here. That'll give me all solutions. That's everywhere on the graph. That's all my intervals where one's bigger than the other. Where this one is bigger than that one. You're welcome, bro.